This demo will show one of the SCAS security tests included in Spirent Security Automation Test Pack, which is based on the 3GPP SCAS testing methodologies. This test verifies the correct handling of a protection policy mismatch by the SEPP SUT. In this test config, we have an emulated SEPP initiator, and the SEPP responder is the SUT. The emulated SEPP initiator triggers the parameter exchange procedure for protection policy exchange. The SEPP SUT responds with a 200 OK if the received policies match. If there is a mismatch, the SEPP SUT will instead respond with a 4XX or 5XX status code. Our security automation solution combines three Spirent products. Velocity, which is responsible for orchestration. It manages the test topologies and the resources. iTest provides the automation framework. It controls test execution, including repeated test iterations for gold-seeking tests. It also performs the result analysis to determine the pass or fail. And Landslide is the execution platform. It's connected to the SUTs and home of the automation test pack libraries. I'm going to run this security test from the GUI, but it can also be run via an external API. So here you can see the automation assets, and under there we have the repositories, and here we have our security tests. If I look at the SEPP folder, we have 6 SEPP tests, and these are all individual test items managed and run by the security automation solution. Each test can be run manually from this GUI, or it can be run through an external API. We're going to run the policy mismatch test, which is this test here. There's a topology associated with the test that defines the resources that are needed. We also have parameters specific to this test, and the user has the ability to override any default values. So if you need to customize the test to meet your network configuration, so like, for example, the PLM ID or the SUPI, things that are specific to the user's network configuration, that can be done here. We also have in the test case parameters section, we have the different encryption policies that we have configured in our emulated SEPP initiator. So those are the values that we've got configured for that test. They can be changed if you wish. So I'm going to run the test, and then under reports executions, I can see that the test has started. While this test is running, let's walk through the results from a previous run. So you can see the objective of the test, and the purpose of this test is basically to verify that the SEPP SUT identifies a mismatch in the protection policies and does not establish the N32-c TLS connection. The topology shows the resources that are allocated or being used by the test. And then in the statistics, you have information about the test duration, a summary of the different types of messages that were seen. The artifacts are additional result files from the test run. And then we move on to the execution messages. The execution messages provide a step-by-step guide of what happened during the test. So when the test starts, you can see the different parameter values being applied. And if we had changed one of the parameter values and customized it, we would see that value being applied during this part of the results report. So the test is being run now. And then when the test completes, we pull out the KPIs that were identified for this test, and we compare them to expected values. So we're looking at the parameter exchange messages for the protection policy exchange. We expected 1 request, and we see 1 request. We expected 0 successes because the SUT is going to reject the policy exchange request because of the mismatch. So here we see the successes reported are 0. And then we look at the failures. We expected one failure and we got a failure report back. In addition, the test collects the CPU utilization and memory utilization of the SUT and compares that to defined thresholds. Those thresholds were defined in the parameter section, and it will make a judgment based on that. So it's looking at the acceptance criteria to determine a pass or fail. And basically, you can see here that the policy mismatch test has passed and the execution time was 2 minutes, 11 seconds. So what that means is that if there is a policy mismatch in the information sent from the initiating SEPP, SEPP SUT has rejected that, and so therefore it's behaving correctly. We look at the PCAP file from that test run, we can see the exchange capability, and the first exchange parameters are against the cipher suite list. The second exchange parameters are for the protection policy information. And then we can expand on that. And we see that our initiator SEPP, so this is the emulated SEPP initiator, is configured for UEID, location, and key material. And because the SEPP under test, our responding SEPP, is not configured for those values, then we get a 409 conflict in response from the SEPP SUT, and the cause is a requested parameter mismatch. If I go back to my report executions, I can see that the test that I started a few minutes ago has now completed successfully. So this demo showed how Spirent's SCAS security solution can be run using the Security Automation Test Pack. I ran this SEPP test manually from the GUI, but the test can also be run via an external API and therefore can easily be included into a CI/CD environment.